So welcome everyone to this session on state of state management in React. And assuming all of you are React developers, so this should be really interesting. Now React has been in the market for quite some time, and people have built applications large and small inside it. But there's one aspect of state management which is true and tricky in pretty much any framework you pick. So my name is Pavan Podila, and you can find me on Twitter at Pavan Podila. I tweet mostly about UI things, so you won't find me tweeting about what I ate for lunch or dinner or things like that. It's mostly useful stuff, links to frameworks, new tools, technologies, techniques of doing things, and so on and so forth. I work for this company called Sapient. It's a large financial consultancy in New York and also has offices all over the world. And we build large apps for like financial markets, Wall Street firms, investment banks, and so on. And I've been there for about 3 years now, and I've been doing front end for almost 15 years, starting with Java, .NET, Mac, iOS, web of late, and React Native, and things like that. So React, of course, is my primary chosen framework whenever I build front end applications, but Angular is also equally in my mix, so I wouldn't really be too biased on one or the other. Now, my talk is divided into 4 major sections. We'll start off with concepts, and then we'll take a quick look at a demo based on which we'll be talking a little more about how we can tackle state management in a few different libraries and frameworks within React. Then we'll talk about more concepts, and then finally look at some code, how we can see all these things coming together. So state, this has been a word which has been haunting our front-end world for quite some time. You all start off very simple and sweet, but then as things get bigger and larger, it becomes very difficult to manage. And it almost looks like an iceberg. It looks very naive from a distance. Okay, whenever it looks like a small iceberg from a distance, but when you start really tackling it, you realize there's so much underneath that you never really thought there was. So state in applications like React, it can be broken down into 2 types of states. The one which is actually visible to you is the component state, which is things like what you're selected on the screen, the colors, and the drag and drop interface that you have, or the current highlights that you have on the list and things like that. But what's hidden beneath, submerged under the surface, is the application state, and this is most likely the largest part of your application. And the component state is really giving a small reflection into the application state, because you don't really see the whole application at any time. You see screenfuls of applications, right? So what you see on the screen is a small part of the entire application state. Almost looks like an iceberg. The component state being the visual part, and the application state is what's submerged underneath. Now, once you have state, it also becomes very important to name your state and the things inside your state very clearly. And one of the fundamental concepts from domain-driven design is this thing called bounded context. Now, naming is one of the 2 hard problems of computer science, right? The other being cache invalidation. You must have heard this statement quite some times. So it's very important to pick the right names for your state variables, for the properties, features, etc. You name them incorrectly or not properly, it leads to confusion for yourself and everyone else on the team. So naming things is actually very important. And there's this book called Domain-Driven Design by Eric Evans, which he wrote several years back, and it's worth reading for everyone who's getting into front-end development or software development in general. There's one concept in there called bounded context, and what it really says is that you have terms which make sense within a certain context, and those terms may not have so much meaning or value outside the context. So when you're dealing with your application, you have actually 2 types of contexts. You have the domain, which is what you're trying to represent as visual stuff onto your screen, and then you have the UI. Now, when you create terms within your domain model and you try to map them to your components in React, there is a transition that happens, and you choose different names based on the context within which the name appears. So let's take an example over here. You have a contact model or an entity from your domain, and it has this little field called is delivery address same as billing. But as you try to map this to a UI component on the React side, you're creating a special React component for it and then passing it as a prop. And here you can see that the name is already getting trimmed down. I've created a component called delivery address, so there's no need to add the redundant delivery as a string inside my property name. So it can be trimmed down a little bit, so it becomes is same as billing. And then you're trying to map that particular property to a checkbox. And you see that the property has now changed again, it's become checked. So what you're trying to see over here is that the names change the values and the actual name itself as they switch between different contexts. And you have to choose the right name for the right context. In the context of a checkbox, you don't want to use the property name as is same as billing. because that's not the context, right? You're dealing at a simple input control, which is a checkbox. And in the context and the perspective of a checkbox, checked is a more valid name to have over there. And you're trying to map a value coming from the domain model into your checked property. So this switching of names is actually quite important, and as you start building large applications, you have to pay very careful attention to what names you choose to describe the properties of your state. And as you switch between context between the domain and the UI, you want to pick the right terms to describe what you're trying to do. Now, state itself is not directly on the client all the time. It comes from the server, right? So you normally make a call to your cloud service, you get back a JSON. But once the state reaches the client, you want to actually spread it across your application. And the direction of flow over here is actually important. It is always top down. So data always flows from the top to the down, which is from the root component all the way down to your leaf components. And you don't want to violate this principle. The time you start violating this principle, you start seeing problems inside the way you're managing state in your applications. So the state always starts from the top and then spreads across all the components in your application. And this could be the case like if you have a React application, in the root component will be the app component itself, and then you have several routes, which is based on React router or something. And the route also acts as a place where you collect some feature level state and then spread it across all the components within that feature. So data down is actually very important. It's a fundamental principle of UI design and development. Now here, one more thing you can see over here is that you have two types of components. There is a container component and a presentation component. And this is the two distinct components you will have inside your application. Container components will be the ones which contain the data, and then presentation components are simply pure visual representation of the data itself. They don't know anything about where the data comes from, but they only, given the same data, they always give back the same visual representation. And the container components are the ones which are store connected, and they make a call to JSON or fire off actions which result in changing to the data or the state. Now, if you're going to send data back up, then you need events for that, right? The leaf component, which is sitting way below, doesn't know how to communicate back to the server. It has to only do it through the form of events. And events can have context around them, and that context is used to propagate what the leaf component is trying to tell you. So you clicked on a component which is deep inside your list, but that list is showing you, say, a list of some items, right? If the click on the item needs to change something, then it fires an event, and the event propagates up the hierarchy, and finally resulting in change to the state. Now, if you have frameworks like Redux or MobX, this has become a little easier, and you don't have to really thread the event through the entire list of components in your chain, but you can do it far more simply. But the idea over here is that you have data going down and events going up. So data down, events up is like the mantra of creating a UI component hierarchy inside your application. The next big thing is side effects. This is probably the ones you'll be dealing with for most of the time. In fact, the heart of your application is sitting inside your side effects. So what is a side effect? So this is the mental model you need to be aware of when you're working with side effects inside your application. State is the heart of your application, right? It contains the real data. It's the pumping heart and sends out blood to all the parts of your application. So when you fire an action, you make a change to the state. So actions are the fundamental ways of making changes to the state. You don't directly manipulate the variable itself or the properties of your state, but instead fire actions and keep things very distinct and separate out. So actions are the ones which will actually result in a change to the state. And these changes will cause side effects. So this could be as simple as a click on a button will fire an action, and that action will make a call to fetch some data. So that will be a side effect, right? Similarly, it could also make a call to send off analytics requests, or it could be a change to the UI. In fact, UI is probably the most visible side effect of your entire application. You probably don't think of it as such because when you're talking about front end, UI seems to be the first thing that you see in front of you. But UI is actually an observer of state, and that's the fundamental thing. It's the side effect of actually having state in your application. The ultimate goal of UI development is to give a visual representation to your data. You must have heard of this equation called UI is a function of state. Basically what it means is that UI is just a transformation that happens on your data which results in visual paints happening on the screen. So it's just a side effect. So think about this as the fundamental mental model of your application. Now, some of these side effects can also result in making changes to the state itself. So a classic example is a data fetch, right? So when you make when you fire an action which results in change to the state, that could cause a side effect where you're calling a network, making a call to the server, fetching some data, but that data itself can be pushed back into the state to store as client-side state. And this is a very common thing you would do in your applications. But this overall thing is the mental model that you need to have when you're thinking about side effects inside your application. Now, there are all kinds of side effects. What I've shown you is a small sampling of it, but here are a few more that you might have used inside your applications. Like route change is actually a side effect. You click on a button, you have some action happening in your application that results in navigation, and navigation itself is a side effect. Similarly, animations, right? You did some action and you want to give a visual feedback to it. That's a nice animation that you want to run. That again is a side effect. Alerts, notifications, form validation, data fetches, everything else is actually a side effect of performing some action. So as soon as you start breaking down your application in terms of actions and side effects, things become a little more manageable. So UI development essentially comes down to this. It's about managing state and the side effects it causes. Everything else is actually built around it. So if you can get to this state and divide your application in a bunch of what are the actions that are being fired inside my application and what are the side effects that result as firing these actions, you have a way of sanely managing the complexity in your application. You can scale well also as you build really large applications. Now, managing complexity is at the heart of software development, right? I mean, if you read that book on domain-driven design, they literally have a slogan that says domain-driven design, tackling complexity at the heart of software. So complexity is what you want to deal with. And you can't avoid it or run away from it, but what you want to do is provide a way to manage it properly. So we already know that we have state and side effects. So let's see one more thing which we need to manage this complexity. And that's something called, that I personally call as the SICK principle. Organization. How you organize your application is around these three principles, which is SIC. So what is this principle? The first is structure. If you come up with a structure where your source code is divided into a bunch of features, then you know what your application consists of. Now, normally I've seen when you're first starting out learning a framework or a library, you put your views, controllers, models as the top level folders. But views, controllers, models are not the top level things of your application. They are just the nuts and bolts of your application. If I want to describe a house, I'll say it's a 4-bedroom house or a 3-bedroom house or this many rooms and stuff in it. I don't talk about it has 20 walls and 7 doors. Doesn't make any sense, right? So when you talk about views, controllers, and models as being the top level folders of your application, you're literally saying, I don't care what the features are, but these are the views, models, and controllers, right? And it becomes very difficult for people to navigate and discover things inside your application. You really want to focus on your features. And there's a nice talk by Uncle Bob Martin, if you guys have heard of him, called The Lost Years of Architecture, where he picks up a Rails application and says every Rails application looks like the same thing, views, models, controllers. I mean, what the hell is going on over here? How do I know how my application is different from every other application out there? So features is how you want to organize things. And within a feature, you'll have your files, which kind of build that feature together, like templates and CSS and JavaScript and services, stores, etc. They all go together. So every feature can now be nicely encapsulated and becomes an isolated unit of your application. In fact, you can take a feature of one application, simply drop it into some other application, and you can reuse it by modifying a few things here and there. So features is how you should be organizing things. And if you have really large features, obviously you can break it down into smaller sub-features and organize them within the folders within that feature. So that's about structure. Now, once you have a proper structure in your application and your project, the next thing is to think about the components that are going to describe your application. And you want to use the principle of isolation. Every component needs to have 1 or 2 inputs and very few outputs. So if you look at a React component, the standard inputs would be props, and the output that comes out of an application of a component is the rendered output, the virtual DOM basically, right? And the other output is the events that it fires in the form of callbacks. So if you think of a component as something that receives props, provides a virtual DOM that is rendering, and the events that fire out from it, you have an isolated piece of component that can be reused again and again and again. It doesn't know about what props it receives or where it receives from, but given the same props, it will always give back the same virtual DOM, right? So you can create isolated components this way, almost like a Lego block. You can think of it that way. But once you have structure and isolated components, it's very easy to build an application. It's essentially a composition of your components, right? You build a hierarchy of components where data simply flows through all this component in the form of props. So structure, isolation, and composition are the 3 principles based on which you can build applications, large and really small applications too if you want to. You want to provide proper structure, create isolated components, and then compose your application by just stringing these isolated components together. Any questions, by the way? All good? All right, let's keep going then. So that's the SIC principle, SIC. So if you try to visualize your app itself now, it will have one store. I mean, that's been the industry standard now, where you used to have multiple stores if you come from a Flux background, but now they kind of consolidated and have a consensus of creating a single store for your entire application. But features within your application can have their own little stores, right? So those little boxes inside this big store box are sub-stores of your feature, right? So now all these sub-stores are actually part of a larger store. So the larger store acts as a coordination unit for all the little stores that you have within your application. So think of your application as a common area where you have things which are shared across all the features and all the features themselves. And each feature will have its own store which will contain the data for that feature. So store becomes a coordination unit for across your application. Now I'm going to jump into a quick demo to kind of proceed for the next part of the talk. And this demo is a very classic use case that you see on applications, right? It's a simple form. In fact, the whole notion of front end in the web world starts with a form, right? If you haven't built a form, then you're losing out like 80% of your front end development experience. So so here's a simple form, and there are a bunch of little things going on over here. When I start typing in the username, it's going to do async validation. So it will actually make a call to some mock server that I have, which will validate whether this username can actually be used. So you can see a little validating thing going on over there, right? So that's a side effect. So every time I type a character, it debounces the character typing itself and then does validation on it. Similarly for strong passwords, it will actually validate whether the password is strong or not, and so on and so forth. And I can type in all of these fields. So it's doing validation as I type the fields itself and giving you real-time feedback around whether these fields are actually valid or not. Validation itself, as I said, is a side effect of simply typing in a field. So what I'm really doing is typing a character which is firing an action, and that action results in a side effect, which is validation on the entire form. Now I can click on sign up, but if you noticed, if any of the fields are invalid, the sign up actually gets disabled, right? So that's also a side effect on the buttons. So let's put in some valid email over here. Now you can hit sign up, and sign up can actually result in a failure because it's a network operation, so it can result in a failure. So that's an alert showing up as a side effect of clicking the button over there. I can say I don't want to do any sign up right now, just get out of it, but you can always go back. But when you go back, you don't want the form to have the details it had before. So you want to clear out the form. That's again a side effect, right? When you move out of this particular route, you want to clear everything that happened in that route, kind of cleaning up after the mess you made. So those are all the different things going on inside your application. And I want to now talk about how we can handle the side effects that are happening in a very simple use case like this using some of the libraries that you have within React. We'll switch back to the presentation here. So we're going to look at a couple of things. And these are the three major areas that we'll look at for seeing how we can build side effects using things like Redux and MobX. Now, set state is something you could use if you're building a really simple application, but it kind of breaks down very quickly because it's really a nut and bolt kind of a thing, right? And you don't want to be piecing nuts and bolts as you're building really large applications. You want to build convenience wrappers and other kinds of libraries you want to use to simplify the lives that you have in managing your large application. So let's look at Redux and MobX, and specifically some middlewares. Now, I think you know what Redux is about, but I'm going to still kind of touch upon Redux in a very short way. But before that, keep this mental model in your mind about side effects. Actions change the state, and then the changes to the state result in side effects being performed, right? So this is a mental model based on which everything else will follow. If you look at simple set state in React, your action is simply a call to set state itself, and which results in an effect which is rendering of the virtual DOM. Now, you don't actually render directly over here, but that results in a framework-related activity where it takes the diff between the current VDOM and the previous VDOM, does the patching and diffing, and then applies the patch onto the actual HTML DOM. So that's a side effect that is happening anytime you call set state, right? So it's a very simple model, and right in this model, you can see how the side effect model actually works. If you look at Redux, things get a little more complicated, only because we have a few more actors over here. You have the store, which contains the state of your application. You have actions, and then there is UI. UI will fire these actions, and then actions are then dispatched on your store, and the store will do something internally and create a new version of your state. And then there's the UI, which is observing the state. It gets notified through a subscription, which then results in re-rendering of your UI. Right? So you can see there is a loop going on over here, and the flow of data is always in one way, which is unidirectional. So that's one of the fundamental things in Redux, where you have unidirectional flows of data. The data is always flowing top-down from the store to the component tree. Right? So, but the store itself is doing something to process the actions that are coming in and then creating that new state. So let's just open up the store a little bit over here. So when a store receives an action, in Redux, the actions actually flow through a hierarchy of reducers, right, and also flows through the middlewares in between. In fact, the middleware intercepts the action before it goes through all the reducers. And each reducer's job is to tackle one little feature of your application, build up the new state based on the action that has been fired, and then the store will actually roll up the state across all the reducers and create the new state for the entire application. That's how actually Redux works. And there are middlewares in between, which will actually intercept the action before it reaches the reducers. So you have an option now to actually either handle the action, discard the action completely, or modify the action to do other things. And most middlewares like promises and thungs and sagas, observables, they will work at this layer of middleware where they would process the action and do something as side effect. And we'll see how that works in a few libraries coming next. So the reason why you need middlewares to handle side effects in Redux is because the reducer function is actually a pure function, right? So you can't really do store dispatches or network calls inside a reducer. It's a synchronous call, so it receives the action and the state, and is supposed to give back a new state. So it's a simple, pure function. You can't do side effects in a reducer. So middleware is the place where you can do actual side effects. So in Redux, we have a couple of middlewares where you can perform these side effects. You have thungs, batched actions, sagas, observables. There are a few more actually, but I just kept it simple because everything else is kind of built around these basic middlewares. So what I'm going to do next is focus on the Redux Saga and Redux Observables as the primary middlewares to manage really large applications and side effects. You could also deal with Redux Tunk and kind of do it in a simple way, but as soon as you have lots of actions and stuff going on inside the application, you need a better model to manage these things. And sagas and observables kind of fill in that hole pretty nicely. Now, when you see an application, an action that gets fired results in a new state, right? And as you fire more actions, the state of the application keeps changing. So over time, you can visualize your application state as a version control system where every action results in a new version of your application state. So if you imagine your application this way, you can jump to any point in time, and that's what Redux allows you to do. You can actually do time traveling where you can go back and forth and say, you know what, if I fire all these sequence of actions, I should be in the orange state. Or if I fire a set of actions, then I should be in the blue state or the red state. So you can actually control how your application will look like based on the state it is using to derive itself. So UI again is a function of your state. So given the same state, it will always give back the same visual representation. So think of your application as a state change that is happening over a period of time. Also, actions are the fundamental units of work over here. They don't actually perform the work, but they are signals to indicate what kind of work that needs to be performed. So your middlewares, or it could be other libraries, are really monitoring the actions, and based on the actions, they are causing some side effects. So monitoring the action becomes the fundamental activity inside your stores and middlewares. So let's take an example of what this monitoring an action really means. Now, certain side effects are actually looking forward to certain actions, right? If you have the sign up action, like when I clicked on the sign up button, it's actually waiting for an action to be fired on the click of the button. So when that particular action gets fired, it will actually consume the action, produce the side effect, which is actually calling the sign up service or navigating to a different route, right? So it's waiting on an action, which is monitoring the action and then performing the side effect. Similarly, the validation thing is waiting for a key press. Anytime a field changes, it's going to perform the validate side effect and going to do the form validation of all the fields. So it's waiting for a validation action. And anytime it receives a validate action, it will perform the side effect, which is the validation of the entire form. Similarly, you have navigation too, which is when you click on not now, it goes to a different route, which is simply navigation. So if you break down your application in terms of these actions and side effects, it becomes easy to kind of apply this model at a small scale all the way to really large scale. So Redux observables and Redux Saga literally use this concept. They have a way of monitoring the action and then performing side effects when certain actions are fired on the middleware. And since they're middlewares, they receive the action before the reducer, so they have an option to actually handle the action and do things differently. Totally negate the action, try out a bunch of different things, and even forward the action to the dispatchers. So when you look at observables and Saga, think of this model where you have monitors as established on certain actions. And when then those actions are fired, they'll perform the attached side effects. Now, there's a new kid in town, which is actually not new. It's been in the market for almost 2 years now. MobX is a different way of doing the side effects. So in Redux, you have a couple of different things you have to deal with, right? You have to create the reducers. You have to have this action creators, which is a way of creating functions that produces the actual action object. And then you have the stores. You have to manage all the stores and combine the reducers to create all the reducer trees. And then you need to dispatch the actions itself onto the store. Now, it requires, people say it results in a bunch of boilerplate, which is true actually. So every feature that you create will have to have its own reducer, its set of actions, and so on and so forth. So MobX kind of comes in to really fill in the need for a declarative form of Redux, right? Where you're more intentional, where you're saying, I want to perform this action, but I don't really care how you actually flow the action through a bunch of reducers and dispatchers. That's your responsibility. So with MobX, what you can do is you can create something called as an observable tree, a state object, which is essentially observables. And an observable is a tracked value, which is reactive also, and keeps changing as actions get fired. And when an action is fired, it simply changes the state of the observable. And since it, by name it says observable, someone has to be observing it too, right? So you have observers, which are literally looking at the state of the entire application and then performing side effects. So in MobX, you have some standard observers, which are when, autorun, and reaction. And what these guys are doing is tracking the observable tree that you have inside your application. And when any change that happens, you could establish some logic that says, okay, when my first name changes, I want to create something else. When my first and last name has changed, I want to create a new derived property called full name. So you can establish observers which are watching these observables and then producing the side effects. So you can do something very simple to something very complex, like a click on a button could be an action fired onto the store, which you'll have an autorun or a reaction, which will actually observe this particular store and then perform the side effects. Now, it's very hard to cover all of these concepts in one slide, but I would definitely encourage you to take a look at MobX, because this will simplify the way you manage large applications and applications in general with React. So that's all the concepts I had. Now let's look at some of this in code. But before that, any questions so far? I think I covered a lot of different concepts over here, but if you have any questions, we should definitely take some right now. Yes, please.
What's the difference between Redux Observable and Redux Saga?
That's a very good question. We can actually see that in code, but Sagas and observables, they are very similar in most ways. Sagas are using generators, which is a feature from ES 2015 to manage the side effects. So you have cooperative processing where you establish a generator and a bunch of yield statements inside it, and you're producing actions and consuming and producing more things inside. So Sagas uses generators as the primary way of handling side effects, whereas in observables, you're using RxJS, which is an observable stream. So you receive an action stream, and you come out with an action stream. And in between, you can apply all the operators that you have in RxJS to actually perform the side effect. We'll see some of that in code, so it will be more clear for you. Anything else? Any other questions over here? All good? All right. So let's just jump into code over here now. All right, so let's start with Redux. Right, we're all familiar with Redux, must have used it in the past. So let's look at what a Redux store could look like. When you start off with Redux, you're establishing the store and a bunch of middlewares. Right, so this is a very simple sign-up form. So I have a store that does batching, which is allows you to fire multiple actions at the same time. It has the thunk, Redux thunks for firing off async operations. It also has the router middleware for navigating between routes. Because if you're using React Router, this is a middleware that you can use to switch between routes from code instead of using the link component. So that's how you establish your store, right? You create your middlewares and then prepare the store for handling all the actions. Now let's look at reducers. Now, in a reducer, you are basically dealing with the state of your application. So you'll have an initial state, which is what you start off with your application, right? And this initial state could be coming from local, or it could also be a call that you make initially before you create your reducer store. So you could make, however be the case, this is an initial state you start with for your application. And in the case of the form, we have the info field, which has a bunch of different properties in it. And then I'm tracking the sign up operation, whether it has failed or succeeded, and also the validation, whether it has failed or has validation errors. So this is how I kind of divided my state into 3 different sub features. And then I'll have reducers, which are tackling individual parts of this particular state. A validation reducer will look at actions like a start, fail, end, and the reset form, which is not really doing much. Basically, it's applying the value that you received from the action and then pushing it to the state. And then when the validation start happens, it's actually setting the field in validation that, okay, validation has kicked off. So you can use this to disable, enable buttons like the sign up button, or you can show the validating little field that we had at the top. So those are the kind of things you can do as side effects. So side effects are basically actions fired onto your reducer and dispatchers, right? So someone is monitoring this action, and whenever that action gets fired, which in this case would be the validation start, it will actually perform the side effect of showing the component on the screen. Similarly, you have other reducers which are performing the sign up, and then you also have the info reducer, which is basically taking in values from your form and then just pushing it out to your state. Fairly simple over here. And then you have the combined reducers, because you normally build a reducer tree. You don't want to create only one reducer that handles all the 100 actions in your application. You want to kind of divide and conquer, right? So you break it down into a bunch of different features and then have reducers attached to individual features. And then you compose them into a tree of reducers, which is what you will use, which will be used by the store to pass out the action to all the reducers. Then you have the sign up form itself. Now, in case of the plain Redux form, you do this connect at the bottom, which is creating a higher order component, right? You pass in the state that you want to actually use inside your component, and also the actions that you want to fire from within that component. And accordingly, you have the map state to props and map dispatch to props, which are 2 different functions you pass into the connect function to create a higher order component out of the connected sign up form. And this sign up form is the one which is now having a connection to the Redux store. So in a normal map state to props and dispatch to props, in state to props I'm not really doing much because I'm simply taking the state and putting it onto the form. But in dispatch to props is where I'm actually firing actions onto the store. So when a field changes, I'm going to fire the set field action and also kick off the validation. This is plain Redux, right? There is no middleware over here. So I am responsible for actually doing the validation. So I will have a function like debounce to validate, and I'll do my own validation manually inside the map dispatch to props. Similarly, when you cancel out, you are firing a set of actions. Now, this batch actions is actually quite useful because it also improves performance, because when you fire 3 or 4 actions onto the store, every dispatch will result in a re-render of your component tree, right? Because it's all synchronous. It goes through the reducer tree, produces a new state, the subscription goes through the UI, and the UI will create itself again. So it kind of results in more work being done. But if you only want to react at the end of all the list of actions, then you can actually batch them together. So you can use Redux batch actions middleware and kind of send a group of actions together. This is simpler and easier and also more performant than firing individual actions one by one and then waiting for your UI to re-render every single time. Especially in case of over here where I'm firing like bunch of actions together, it makes sense to kind of batch them together and send it out as one block. In case of sign up, again, I'm dispatching an action to kick off the start of the sign up, so I can do some validation and show some visual feedback that hey, something is happening. When the sign up completes, it could either pass or fail, and based on that, I'm firing actions indicating that it has passed or failed. So that's how a normal Redux component would look like. Now, if you go into middlewares like sagas and observables, things get a little more simpler now, right? So if you look at the sign up form in case of the Redux saga, you'll see that there's not much happening inside this component itself. It's only firing actions. There is no work being performed over here. You're simply dispatching a bunch of actions. That's all. No work being performed. So who's actually doing the job over here? Who's actually validating it? Who's actually routing between different routes? Well, that's all happening in the middleware now. So if you open up the store for Redux Saga, you will see that your store looks a little bigger now because you're establishing the sagas, which are a way of capturing side effects against a certain action. So we have 3 different sagas going on over here, 3 different side effects. We have the sign up saga, you have the validation saga, and then the navigation, right? And each of these sagas is essentially monitoring an action. If you look at the sign up saga, it's waiting for the sign up action. And anytime the sign up action is fired onto the Redux store, it will perform the sign up. And which will basically mean it will go over here, it will start the sign up. It can actually fire actions of its own and do the job and then fire more actions. This is a way to kind of handle the entire side effect in one place now. It also becomes easy to test it. You can now test your side effect more easily than having to do testing with plain Redux, where you have to kind of mock a bunch of different things and do things together. So sagas actually manage side effects for you by creating these generator functions. And whenever you yield, it is actually giving the control back to the saga middleware to actually do something with the action itself. So you can yield put an action, you can yield call, and calls can call a promises or any async operation. And so in this case, I'm calling the sign up function, which is an async operation, right? And passing in the form data, which needs to be used to actually do the sign up. If the sign up succeeds, I'll fire the sign up completed. And if for some reason the sign up fails, the promise gets rejected, the catch block will be called automatically. And this is how the generators actually work in ES 2015. A rejection of a promise results in the catch being called in the try catch block. So it will fire an error, and that error can be caught over here, and I'm simply firing the failed action in the catch errors. So you can see that how things have become a little more simplified now. Your async operation, which was split across say multiple different functions maybe, can all be seen as synchronous code. It kind of looks, everything is in one place, and you know that what is the failed action, what is the successful action, and you can see what the whole side effect looks like when a sign up is being performed. Now, some of this code might look alien, and it's okay, but focus more on the concept and the idea, and you can always read up more about Redux sagas. But using generators and these yield statements, it becomes easier to manage side effect against a certain action. Similarly, if you look at the navigate side effect, it's waiting on the, which is over here, navigate to cancel saga. It's waiting for the sign up cancelled action and then putting the reset form and then pushing out. And so this yield push is actually switching the routes over here. So you're doing a bunch of different things, which is the entire side effect when you hit on the cancel button. And similarly, you have validation, where I'm throttling the action every 500 milliseconds. So if I'm like a crazy typer and I'm typing very quickly, I don't want to handle every single key press. So it'll actually debounce for 500 milliseconds and then perform the validation. So this is how side effects are managed in sagas. Now if you look at observables, things are again very similar. So to your question about how sagas and observables are similar or different, the component itself again looks the same. There is no work being performed over here. It's simply dispatching actions. Right? When a field changes, I'm going to just simply dispatch the field change and the validate action. The work itself is not being performed in the component itself. That, of course, is being done in the middleware. And so your stores look a little big now. Now, in Redux observables, they use the term called epics, which is a Redux observable stream operator, which is looking at an action stream, which is a stream of actions flowing into your middleware. Right? So you're basically firing a series of actions. So you have a stream of actions, and in RxJS, you have this notion of continuously produced values. So your stream consists of continuously producing values. And you can apply operators to the stream, you can manipulate it, morph it, transform it, switch to a different stream. You can do all of those things using the RxJS operators. So in this case, you create 3 epics. So with Redux observables, what you do is you create one root epic, which contains all the sub-epics that you want to handle. So all of the side effects are parallel side effects, right? So you could handle the validation, the sign up, and navigation cancel, and you can have many more also. And you can have epics that can do more epics inside. So essentially, you are dividing and conquering across the side effects. So you establish the root level epic, which will now be the place where things start branching off. So if you look at the sign up epic, it's receiving a stream of actions, and this action $ is just a convention in RxJS where you signify a stream. The input of a sign up epic is a stream, and the output is also a stream of actions. And everything in between is just a bunch of operators and RxJS operators. So let's see how it happens over here. When you receive the action stream, if it is of the type sign up, which is literally a filter call, you're filtering on the actions of type sign up. you are switching the map, which is saying that I'm going to switch to a different stream now. And in this stream, I'm going to look at the form data that I received, which is in the action. This is the payload of the action, right? When you call sign up, you're passing in form data as the payload of your action. You're going to now concat and create a bunch of actions over here. The first action I'm going to fire off is the started, so that I can show some visual feedback. Then I can fire off a promise request to the sign up call. And when the promise succeeds, I'm going to fire off the sign up completed, resetting the form, and then switching the route. And if it fails for some reason, then this catch will get called. And in that, I'm going to simply fire off the failed action. Now, things look a little different over here because of the operators coming in, and this looks like a lot of boilerplate. But essentially, that's what you're trying to do. You're establishing a stream where the action flows through the stream, and then you're applying operators to handle that particular action. And each of these operators could actually be resulting in firing off the side effect or firing off more actions onto the store. So that's how a sign-up epic looks like. Navigation cancellation is, again, very simple. It looks at the action stream, filters out the sign-up cancelled, and then switches the map, which is basically saying, produce a new stream of actions now, consisting of the resetting of the form and then the route action. Right? So you're essentially producing a new stream consisting of these two actions. And the way the Redux observables middleware works is that it actually takes in the stream and then passes that stream of actions through the store. So every action you produce in this particular stream will be done as a store.dispatch on your final store, and then passing through all the reducers. And similarly, you have the validation epic. So here you again filter out on the validation call, debounce it by 500 milliseconds so that you can take care of the crazy typers. And then you switch map and create a series of actions. One is to start the validation so you can show feedback, and then you can fire off a promise request because I have an async validation going on. If it succeeds, I'll call the validation end. If it fails, I'll call the validation fail. So this is how you can manage a side effect. And testing it is also quite easy. You just produce a stream yourself and then fire off actions onto the stream. And you can see whether it actually resulted in a change to a certain state. So with Redux observables and Redux sagas, you can actually manage the side effects far more easily. Now, one last thing I want to cover is MobX. And you can try to contrast to see how things are different in MobX now against Redux. So in MobX, things are again the same. The sign-up form is slightly different because instead of firing the Redux actions, I'm simply making function calls into my store. And in MobX, what you do is you create a store which contains all the observable properties. So in this case, my info is an observable property because it will keep changing, so someone has to react to it. So I'll mark the whole info block as an observable. Similarly, I have the sign up, which is also an observable. So what it does is it starts tracking anytime there's a change to any of these properties. And validation also is an observable. And then there are actions, very similar in concept. Right? We have the same side effect model where actions are being fired. So this is an action where you are setting the field value, and all you're really doing is setting the field value. And the act of doing this actually results in a notification getting fired off. Right? Whenever you change a field of an observable or a property, a value of an observable, there will be trackers or observers who are waiting for things to change. And when they change, they will perform the corresponding side effect. So when the field changes, I have established the reaction on it. Right? So right in my store, in the beginning of the store when I'm constructing it, I set up the validation. And what I'm doing over here is waiting for the info observable to change. So look at what happens inside the setup validation. I have a reaction, which is react anytime there's a change to these observables. And just the fact of dereferencing a variable will be an indication to the MobX observable tree that something has changed, and it will fire off the corresponding side effect for you. So in reaction, what you're really doing is dereferencing all these variables because that's a cue to MobX that track these particular properties. And whenever they change, I'm going to perform the operation over here, which is the place where the whole side effect is happening. So you can see all I'm really doing is modifying observables. I'm setting the pending to true, then firing off an async operation, and then if it fails, it'll if it succeeds, then we'll cancel out the error and set the validation to true. If it fails for some reason, then I'm going to set error is the actual error and the valid to be false. And then finally, the pending to be false in the finally block. So you're really dealing with the state over here. It is not an action that is being fired. and someone is actually waiting on the properties to actually change and reacting to it whenever those properties change. So you can have observers right inside your store, but you can also have observers set up right on the component itself. So the sign up form, if you noticed, has an observer over here. Oops, sorry. This is an indication in MobX using the MobX React package that I'm going to monitor the store, and any observable that I'm tracking inside my render, it will result in a re-render of the entire component. So if the username changes, this whole form will re-render itself and then show the new change. So this is a different way of actually performing the side effects, where you are kind of focusing more on the state itself rather than a series of actions and side effects as two distinct things. You're kind of combining all of them together by using decorators, which is this decorator syntax, and kind of doing things in a little more declarative way, right? So you're not really manually firing off actions and waiting for things to be produced through side effects. You are simply firing actions. You're just making calls on the store and establishing observers on those observables. Anytime those change, these observers will kick in, make a change, cause a side effect, and produce more changes to the state. So having these different ways of doing things is actually quite nice, and I'm personally a big fan of MobX, and almost all my React projects use MobX now. I used to use Redux before, but after using MobX for almost a year or so, I can't imagine going back now. So I would definitely encourage you to take a look. Even if you're not a believer right now, I think you should at least try it out. Hopefully you'll like it. All right, so that's a lot of code, a lot of concepts, and it's quite overwhelming even for me to speak about all these things. So I'm sure you have questions. So let's take a few of those right now then. Yes, go for it.
Is that decorator syntax transpiled down?
Yep. Yep. So we use a different plugin for that, the Babel plugin. So let me just quickly touch upon that too. So all I have is a simple Webpack setup over here, and one of the things I'm doing is this Babel preset, which will take care of the Babel plugin. Sorry, where is it? Oh, it's over here. Sorry. So you use this transform decorators legacy. It's a weird name because decorators is not yet an approved proposal for TC39. So that's the reason why they call it legacy. And if it gets approved, they'll just strip off the dash legacy from it. But it's a plugin which will actually transform that particular syntax into just a function call, because decorators are essentially just a function wrapper around that whole thing. So that's what it comes down to. So this Babel plugin takes care of doing the transpiling for you. So it's ES5 compatible as well. Yep. Yep.
How does the tooling for MobX compare to?
That's a very good question. Yeah, so MobX has similar tools like the Redux, what is that? The Redux dev tools. So it has its own similar dev tools called MobX dev tools. And here you can do things like tracking whenever there's a change. So I have turned on this little MobX dev tools. And the way you put this dev tools on is by simply going into the MobX, the root component, and adding the dev tools component over here. And you can have a little webpack flag __ dev or something like that, and you can use that to switch out between this component or something else. So you can have the production versus development modes. And just having this component over here will give you this little toolbar at the top. And what this toolbar does, it allows you to monitor how the re-rendering is happening inside your application. So now when I type, notice that whole thing flashing as green, right? So that's basically the dev tools coming in and painting the flash for you. So that's a tool that you can use. You can also click on any component to see what are all the observables that are being tracked inside this particular component. So obviously I'm tracking a lot of things over here. I have the username, the last name, and then the bunch of validation properties. So all of that is being tracked over here. So that's what you get from the dev tools, the MobX dev tools. And what I've done over here is not the most performant way of actually building this form. Ideally, what you want to do is create little components which are their own observers. So anytime this component changes, I don't want the whole form to re-render itself, right? Doesn't make any sense. It's just a wasted effort. So you can actually create an observer right around this component and pass it the observable which you want to track. And so anytime this field changes, only that field will be re-rendered, which is actually faster also. You don't have to go through all the components inside your React tree to re-render themselves. So dev tools can be used to kind of see, okay, which components are being re-rendered too frequently. or which one should not be rendered at all, and so on. All right. Yep.
If you had to rate the complexity of using MobX versus something like Redux, where would you put it on a scale of like 1 to 10?
Yeah, I mean, I hate these kind of questions where you have to put one number on the whole thing. It's a very qualitative answer, frankly speaking. If you're coming from a Redux background, you will see that the things which you normally do in Redux, you don't have to do it anymore. Like manually firing of actions, creating those action creators, setting up a reducer, and then having the connect call for every component that is connected to the store. Right? That's extra work you have to do personally. And one way to mitigate that would be to create generators, right? You have a Yeoman generator or a plop generator or some scaffolding tool which will come in and spit out that code for you. But that code is still there, right? So if you're in the Redux world, you will see that there is a lot of extra files and stuff you have to manage with. With MobX, you don't have so many files. Everything sits in one store, and you're primarily dealing with data objects. So your store is the place where you have the single source of truth. And it's not spread between reducers and the initial state and the action creators. There are three different things which are trying to kind of manipulate the store in case of the Redux world. Whereas in MobX, everything sits in one store. So you know what actions are being fired because I have decorated my functions with the @action decorator, right? So I know which ones are getting fired from my Redux components, sorry, my React components. And then I have these reactions or auto run or when, which are the observers of my observable, right? So right at the top of the store, I'll have all the observable properties. Right? This is how I'll set up the store itself now. And notice that everything is together over here. There's no initial state. There is no reducer. There's no 2 or 3 different files that I have to jump to kind of see how my state is getting manipulated. It's all in one place. And if you have more complex stores, you can create other classes, and have classes with their own observables. They kind of break down the whole thing. So in case of the info field, if you think that the info is getting a little bigger, you can actually create a new store called the info store, which is also a MobX store, and then have this whole observable pushed inside that. So here in this case, I could do something like this. I can create a class called info store, and I can take all of these guys. I can just paste it over here. Yep, I have the syntax issue, so let me just take that, and I can add the add observable over here, right? And I can do this also onto this guy. Oops, sorry. So this way now you can move the whole observable object into the store. And let me just take care of this also. Okay, so you have the semicolons, so I'll strip out on that. All right, so and then instead of doing it this way, you can just say info equal to new info store. That's it. So now instead of putting everything in one store, you can actually create sub-stores which will have all the observables, especially located over there. And if you have more side effects for the info specific fields, all of them can be inside the info store. So that way you can manage complexity as you start growing your application, and just create sub-stores with their own little observers inside of them. So I find MobX to be a much nicer way to kind of do this. I was a big proponent of Redux, trust me. But after using MobX for almost a year now, I just find it way more convenient. But that's just my opinion, but you should try it too, and form your own opinions on that. Yep?
So if you're like clicking a button, you're not really updating a state piece, how would you tell MobX to do something with the observables?
So with an observable, let's take the case of the sign up button, right? So when I click on sign up, it is supposed to fire an action, which is literally a function call in my case. So it will actually come in over here and then fire up this action called perform sign up.
Can we see the JSX?
Oh yeah, absolutely. So in case of the sign up form, this is how it looks like. So I'm actually passing in the on sign up as a callback, which will be the on sign up over here. And here on sign up, I'm simply saying props.store.perform sign up. It's as simple as this. There's all functions and classes. You don't have these actions or action creators or store dispatches. I mean, it's still good. Conceptually, that's what is happening actually. You're dispatching an action to the store, but you don't have the actual mechanics to manually write it down. You're literally saying, fire off a function call. At the end of the day, an action is actually a function call, right? It just happens to be a little more high level, but it results in a function call being fired at some point. So why don't I just do it right over here? So this way it's easier to see what actions are getting fired right from the JSX without having to navigate through a series of actions and reducers and finally coming back to your store. I just find it more easier to read the code in general also, especially for large applications when you have like lots of features and stuff. And especially if you have big features and features with their own little stores, I would create a separate folder for them, put all the stores for the feature right over there with like a feature.store.js, and then all the MobX related stuff will go right inside that. It becomes much easier to actually manage things eventually. So one thing to notice over here is that there is this one single form which is common across all the different examples that are written. This is the connected sign-up form, and it comes from sorry, let me just show it over here. So I'm using the sign-up form, which is the common form which is used across the MobX and Redux examples, right? So this is where I'm putting out all the JSX for the different fields of my form, and it has a bunch of callbacks. So this is the concept of the isolated component, right? I have one component that doesn't care what store or data or what stuff it is getting as inputs. It exposes a bunch of inputs, which is the props, and then has a bunch of callbacks, which are the events going out of the form. And using this as an isolated component, I can create my other components, which are simply acting as the container components. So you can think of the sign-up form as being a presentation component. It doesn't know anything about Redux or MobX or anything like that. It just provides presentation. It's the JSX which contains all the fields. And then you have the connected component which comes from the Redux world. So sign-up form will actually use the connect and then pass all these props into the connected sign-up form. So this is again an example where you have container components and presentation components, and having this separation allows you to even jump between different frameworks and libraries quite easily. Yep.
So do you still use like local state on any components just to handle tiny?
Yes. So this doesn't mean that you should never have state on components. You can still have state actually. So and this is so component state would primarily be state that doesn't have to be persisted. Right? So this could be like selections and highlights or anything that is at a UI layer, which is only for that particular session. Anything that you don't want to persist in a store. But sometimes you want to push that state also into the store. Like let's say you have selected some song in your library, and you want to play that song every time you open up the library. So that could be a persisted value. So that could also go into the store. So you can start off with the component state, but slowly push it down to the application state. So going back to the original diagram. Yep.
Can you make it so that the observables are immutable, so that they erase errors if you try to change them without action?
So observables are actually mutable values, and the fact they're mutable is what gives the advantage to MobX.
I mean, you could do input of first name equals in the component, and nothing's going to happen now. But can you make it so that it would raise an error?
Yes, you can. Absolutely. So you want to say something like this, right? So I type in over here, and then you want to raise an error as soon as you type in, or?
No, it's more like if I write, I don't want to write code so that I accidentally mutate.
Oh, I got it. Okay, yeah.
Kind of a little bit like the Redux.
Yep. So there's actually a property in MobX called use strict actions, which actually fires an error anytime you modify an observable which is not part of an action. So let me just do that and see if I can do it over here. Oops, jumping too much. Let's see, it's right over here. I think it is use strict action, or I think you can just take it like this. I forget whether it is actually an exported value or a default value. So we'll figure out. So I can just say mobx.use strict equal to true. I think that's how it is. So and now if I don't put my changes to the observable inside a action, it will fire off a error. So let's take this one and just comment it out. So now this is a plain observable manipulation, right? You could do this inside the JSX itself, which is actually a bad way of doing it. You want to do it as part of an action. So now let's look at the console and see. Let's clear it out. Now that's working. I think I have to get online to see this now. The API might be not correct. But essentially, you have something like this.
Okay.
And it fires a error anytime you modify an observable which is not manipulated inside an action. So this way you can actually put some guarantees also. All right. Cool. All right. Thanks, guys. Thanks so much.